Hello everyone. This video presents Age of Information approaches for real-time network anomaly detection. This work has been carried out under the European Union Horizon Europe MSCA Doctoral Network Project, Secured and Intelligent Massive Machine-to-Machine Communications for 6G. We gratefully acknowledge its support and contributions. Imagine a smart factory where thousands of sensors are monitoring machines in real time. Everything appears normal until suddenly a critical failure happens, but the system didn't detect it in time. Not because the data was missing, because the data was too old. Now imagine an autonomous vehicle moving at high speed, reacting to information that is already slightly outdated. Even a small delay could lead to serious consequences. In modern intelligent systems, the biggest challenge is no longer just speed, it is the freshness and reliability of information. For decades, networks have been evaluated using metrics like throughput, how much data we can send, latency, how fast it arrives. These metrics are important, but they do not tell the full story, because even when data arrives quickly, it may no longer reflect the current state of the system. In today's systems, especially in industrial control environments, decisions must be based on information that is both fast and timely. This is where Age of Information, or AOI, becomes essential. AOI measures something simple but powerful. It gives us the time elapsed since the most recent update at the system was generated, not when it has arrived, because in real-time systems, even perfectly delivered data can be less useful if it is not sufficiently fresh. In industrial control systems, this becomes critical. Sensors continuously monitor machines, networks transmit updates, and controllers make decisions in real time. This creates a tight feedback loop. When the information in this loop becomes stale, faults may be harder to detect. System responses may lose accuracy. Operational efficiency may decrease. Even small reductions in freshness can impact overall system performance. Similarly, in autonomous and connected vehicles, decisions rely on continuously updated information. If the system reacts based on slightly outdated data, it may not fully reflect the current environment. In such systems, information freshness directly affects decision quality and safety. Consider anomaly detection in these environments. Anomaly detection refers to identification of rare item or events that differ significantly from the majority of data. It plays a critical role in detecting faults, intrusions, and unexpected system events. Anomaly detection has broad applications in areas like cyber-physical systems, healthcare, and modern communication networks. Modern systems rely on AI to identify unusual patterns and detect potential issues. However, interpreting these patterns correctly depends strongly on the timeliness and reliability of the data. Without this context, decisions may become uncertain or inconsistent. By incorporating Age of Information into the analysis, systems gain a deeper understanding of the data they process. Instead of relying only on observed patterns, they also consider how recent and relevant the information is. This leads to more stable and informed decision-making. We recently conducted a study to explore the role of Age of Information in anomaly detection. In our work, we analyze how AOI interacts with other network attributes and design an anomaly detection framework that considers both data behavior and data freshness. Unlike traditional approaches, our method does not rely only on raw network observations. It also evaluates how timely and reliable that information is. The results were quite promising. Our approach achieves high detection accuracy, low false alarm rates, strong performance in time-sensitive industrial environments, demonstrating that AOI can significantly enhance real-time anomaly detection systems. As networks become more intelligent and autonomous, performance can no longer be defined by speed alone. The real question is, how well can a system leverage relevant and reliable data to accurately detect anomalies and respond promptly? Thank you.